Let's review simplifying radicals to get us started this semester. So I have a couple methods I want to show you on how to simplify a radical. So I wrote down here at the top, there's two, in my opinion, there's two ways to go about breaking down a radical into lowest terms. The first one here that I have is to find the largest perfect square that goes into the number under the radical. And so what I mean by that is, of course, perfect squares are integers that are the result of another integer squared. So for example, 4 is a perfect square because 2 squared is 4. Actually, if I go back one number, 1 is a perfect square because 1 squared is 1. But typically that doesn't help us simplify radicals, so we bypass it. The next one would be 9 because 3 squared is 9. Then 16 because 4 times 4, 25, and then on and on. So if we can identify or locate, or I guess not locate, if we can recognize that these numbers go into a number, then I can take the square root of these and get an integer. Another way is just to break your number down kind of like a prime factorization tree, and then we can find pairs of numbers to take the square root of. Okay, so let me go through, or let me briefly talk about what I have here. So when you've got an item under parentheses, and this example is a times b, it can be separated into separately the square root of a times separately the square root of b. Okay, and so an example of that would be, let's just say you have the square root of 8. So I can separate that down into two values that multiply up to 8. So 4 and 2 multiply up to 8. So I can break square root of 8 into square root of 4 times square root of 2, and it's equivalent to itself. All right, so that's what I'm going to do kind of with method number 1 here, finding the largest perfect square. Okay, so 72. So you could go about this several ways. You could go about this by taking each of these perfect squares and seeing if they evenly go into 72. Or you could just start by saying, okay, 72 divided by 2 is 36. 36 is a perfect square, okay, because it's 6 times 6. So one way to do this is to break this down into square root of 36 times the square root of 2, because 36 times 2 going back up to 72. This particular factor is a perfect square. So if I take the square root of 36, I get 6. Square root of 2 is a decimal, so it just drops down. And you can put the dot there, but keep in mind, when two items are next to each other, it's implied multiplication. And so 6 times the square root of 2 is a simplified version of the square root of 72. You could type both of those into your calculator, you'll get the same decimal. Okay, but what if you don't recognize your perfect squares really quickly? Let's do the, I guess the factor tree, I guess. So I'm going to start with square root of 72. And so I know that 2, we just said 2 and 36 is 72. So now I'm not going to go ahead and put the radical above it for this tree, but keep in mind it is really there, but I'm trying to just break down into prime factors. Okay, 2 is done, but 36, so 36 divided by 2 is 18. So 36 will break down into 2 and 18. Let's go with 18. 18 divided by 2 is 9. But 9 can break down 3 times 3. Okay, so here's what I'm looking at. I'm focusing on the 2, this 2, and then these 2 3s. I'm focusing on the very bottom of each branch, I guess you could say. So what I'm doing is looking for pairs here. All right, so here's what I'm looking for. I see a pair of 2s, I'm gonna circle those, and I see a pair of 3s. So if you remember, these are all under the radical. So if I have square root of 2 times another square root of 2, you have the square root of 4, which is really 2. So when I have a pair of numbers, that is going to represent, when I take the square root of both of these 2's right here, that's just going to represent 2. All right? So I have, over here, I have 2. okay, because that represents the first two. I have 3 times 3, and so the square root of both of those would end up being 9, which the square root of 9 is 3. So I have 2 times 3. And then when this doesn't have a pair to go with, that's going to stay under the radical. And so then when I combine these, I get 6 square root of 2. Okay, so I get the same answer. It's just sometimes I find students don't know their perfect squares very easily, and so you spend a lot of time typing into your calculator and trying to figure that out. So if you break it down by factor tree, and when you look for pairs of numbers here, that becomes a single 2 on the outside, because really, remember, it's the square root of 2 times square root of 2, which is square root of 4, which in essence is a 2, okay? So let me go through both methods here for several problems, and honestly, you just pick which method you like. Okay, perfect squares. So if I start out, if I do 48 divided by 2, I get 24. 24 is not a perfect square. 48 divided by 3 is 16. 16 is a perfect square. Okay, square root of 16 times square root of 3. Of course, square root of 16 is 4. And I know 3 cannot break down any further, so I know I'm done. Okay, let's try factor tree. Square root of 48. Okay, 2, what did I say? 48 divided by 2 is 24. 2 times 24. 24 breaks down. 24 divided by 2 is 12. 12 breaks down. 2 times 6. 6 breaks down. 2 times 3. Okay, so let's look for pairs. I've got a set of 2's, a set of 2's, and 3 is going to stay under the radical. Okay, so this will become just a single 2 on the outside of the radical. This will become a single 2. 2 times 2 is 4. 4 square root of 3. All right. Okay, I would like you to try number 3. If you want to just pause and continue on, you can, but try number 3. All right, so pause the video and then come on back and let's check the answer. Okay, perfect square method. Divide by 5. 5 and 16 is 80. Square root of 16 is 4. So it's 4 square root of 5. Factor tree method. So 80. 80 divided by 2 is 40. 40 is 2 and 20. 20 is 2 and 10. 10 is 2 and 5. All right, I've got 2, another 2. 2 times 2 is 4. 5 is staying. 4 square root of 5. Okay, let's look at number 4. Because I want you to notice how it's a little bit different because there is a 2 here in front of the radical, all right? And so really what that is just saying is 2 times the square root of 50. So any number I bring out of the radical just gets multiplied by 2. Okay, so perfect square method. So keep your 2 in front. 50 is 25 times 2, and 25 is a perfect square. So this 2 will come down here. The square root of 25 is a 5. Square root of 2 stays the square root of 2. So now that 2 and 5 are out of the radical, they can be combined into 10 square root of 2. Okay. We can do the same factor tree method. So what I might recommend here, the 2 in front, I'm just going to write it over here to the side. I know I'm going to do 2 times something. And so just separately break down 50. So 2 and 25. 25 is 5 times 5. So I have here a single 2 that stays under the radical, but square root of 5 times square root of 5 is 25, which is really just a 5. All right, so I have a 5 to come out of the double 5s. I've got square root of 2 here, and then there is my 10 square root of 2. Okay, so that is a refresher on simplifying radicals. So I would like you to try the last 4. I'm going to stop the video, work through the last 4, come on back, and I will quickly work through them. Okay, 20 square root of 4 square root of 5. So 2 square root of 5. Okay, and if I do the factor tree method, 2 and 10. So I always start by dividing out by 2, 2 and 5. Okay, so I have here a pair of 2's. So that will just be a single 2 out of the radical. 5 is going to be staying under the radical. Okay, 2 square root of 5. Okay, number 6, 4 stays out in front. 125 is going to be 25 times 5. So that is underneath the radical right now. 4 is coming down. The square root of 25 is 5. Square root of 5 stays. So I end up with 20 times the square root of 5. Okay, and then factor tree method. I'm going to keep my 4 over here, and I will just do a factor tree off 125. 5 and 25. 5 times 5. Oops, let me get another color here. So I'm just going to circle these two 5s, and that will stay. So these two 5s will produce a single 5. The one that doesn't have a pair is under the radical. 20 square root of 5. Okay, let me just finish these last two. Perfect square method. If I divide this by 2, I get 225. Now, I know 225 is a perfect square. You may not recognize that, though. So that is the disadvantage to the perfect square method, is if you don't know your perfect squares, then you're not going to recognize it right away. So this would be 15 square root of 2. So if you do the factor tree method, you should still get that same answer. And then lastly, 7 is going to stay. 75 is going to be 25 times 3, right? 75 divided by 3. Yeah, 25 times 3. So square root of 25, square root of 3. Square root of 25 is a 5. And then 7 and 5 oops, not 13. 7 and 5 multiply back to 35, square root of 3. Okay, so hopefully one of those methods you connect with. If you have any questions, though, please email me, or if you have another method you feel like is easier that maybe I want to share with others, please share that as well.